Hi, welcome back to Book Club. Again, we're in Rocket Propulsion Elements. This is a phenomenal book. As a reminder, Book Club is about, like, y'all go read this. This is good stuff. This is where your learning comes in. Dig in. I'm just here to hit the wave tops and kind of maybe teach some of the concepts that are hard to understand. It's really a phenomenal book. Kind of go dig and read. And now we're kind of in chapter 12 and 13 for solid rocket motors. Now, I have a lot of experience doing liquid rocket motors. We did handle a couple solid rocket motors at Virgin Orbit, so I do have some familiarity, but I would not call it expertise, certainly by any means, but certainly enough to kind of give you, again, the wave tops, dig into the book. And this is sort of, I think, one of my favorite pictures of solid rocket motors is actually the space shuttle. And the reason, because of it, is actually that, we sort of, you can see the big plume, and we always imagine the space shuttle and that beautiful launch, but what you're actually seeing is the solid rocket motors, right? The hydrogen oxygen engine, the space shuttle main engine is on, but hydrogen oxygen flame is clear, okay? And so you don't see it. In fact, a lot of people who are working hydrogen combustion, one of the things you have to do from a safety point of view is you actually walk in front of you. I think I mentioned this before. You walk in front of you with a straw, as sort of as you're doing kind of approach to a stand that might be hazardous. Because if there's a hydrogen flame, you're not going to see it, and so you're walking with a straw in front of you, and then it'll burn the straw, kind of straw broom. So safety tip there. But yeah, this is what you were actually seeing on the space shuttle launch was the solid rocket motors. Okay, and so the first sort of thing is I said motor and not engine. That's one thing that I don't know why the industry stuck with that, but we're very consistent. Which engine means liquid, and motor means solid. Don't ask me why. It's nice. So solid rocket motor, but if you're someone talks about, like, it's Venus when they say, hey, how's your rocket motor? I'm always like, it's an engine. Okay, but that's just sort of an inside the industry thing. But one of the benefits of solid rocket motors is long storage. Okay, so but this is why they're in missiles and weapon systems, things like that. Is usually, 5 to 20 year is not a big deal. Not a big deal. It's not surprising to see that kind of this requirement that they can go do it. Now, solid rocket motors are simpler in some ways. Hey, they can be more hazardous in some ways. And so usually what you get with the solid rocket motor approach, I'll say simpler here. I'm not opposed to saying simpler. But usually what you sort of get for all of this is less ISP, but more density, for sure. Okay, for sure. And so that's why 100% for smaller systems, solid rocket motors win. So you just can't get a liquid in there, you can't pack enough propellant in there based on all the other things you have to carry with the liquid. Like turbopumps and tanks and valves and things like that. So there really is a size historically that we just, below that, it doesn't make sense. Okay? And so that's some of the benefit of it. Some of the downsides, I'll try and switch to orange now for some of the downsides, is there really is no acceptance testing. It's not like a liquid motor where you can put on a stand, sorry, liquid engine. I did it. It's not like a liquid engine where you can put on a stand and fire the liquid engine and kind of verify it's good, and then take it from that and be like, now this engine's good, go bolt it onto the launch vehicle. There is no version of acceptance testing your solid rocket engine. You might do a qual test where sort of you've used one and said, okay, this is doing the performance we want, but every additional one you make, there's no acceptance testing. You would still declare and assess quality control steps and things like that, but from a rocket engine point of view, there's no acceptance testing. Okay, and then I'll just say limited thrust control. And what I mean by that is you basically can control the burn. Okay, and so I'm going to start drawing a diagram here of solid rocket motor, and here's your sort of circular diameter. And I'm going to draw sort of, there's your diameter and then engine, okay? There is a grain in here, so I'll just do like a star pattern, okay? Now, this is clear, sort of open to the air, if you will, and what I'm drawing there is sort of down the pipe, and then the pattern is sort of opposed sort of running around here. Okay, this would be an example of a solid rocket motor. Okay, and close off at the end. And so what's happening when you light it is the area in here, let's see if I can get away with this, is, well, kind of dot, 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 dot. You are actually loading the fuel and the oxidizer together in a blend. And it's solid, okay? But these grains are mixed. So it's mixed solid and your oxidizer and your fuel. And then what you do, you pick a mixture that has to get to some temperature to get going. Okay? And then you would have, almost like a regular rocket engine would have, you have some sort of side reaction here. Usually it's another solid, but it's usually different choices of solid that actually reacts at a lower temperature. And then usually you got some sort of like spark or something to primer to get it going. So it's not too surprising sometimes to sort of see a three-stage process, like a spark to a primer to a secondary to a main stage. And that's all from a safety point of view, and we'll talk for sure about safety. Really, this is there's a lot of care and handling that happens to solid rocket motors. Now, we've gotten good at it, we understand, but that was sort of all of the operational systems we do for solid rocket motors came in the world of engineering. There are things that we do and have done that we've paid for the price in blood and lives. Okay, and solid rocket motors is for sure one of them. And so there's a lot of care and handling and no cell phones around it, no radios, like electromagnetic radiation, charge, buildup. There's quite a bit that goes into care and handling of solid rocket motors. Now, we've got it down operationally where, again, I'm in the Navy. In fact, I just came off Navy duty. That's why I'm all shaved. Like, where we do this out at sea and have 18-year-olds carrying, missiles and putting them onto jets. So we can make it safe, but it's safe through a lot of safety processes and double checks and things like that. So it's always challenging. Okay, and so what happens when you light this off? This pattern is going to then burn, and so there are tweaks you can do to the pattern. Okay, and so when I say limited thrust control, because it all comes through the pattern and how you blend it, and so at some point you can usually it's a sort of a neutral cross section. You're trying to maintain thrust. Basically maintain a constant area as sort of the solid burns away. It burns on the surface and sort of recedes. But you can have ones that sort of are progressive, or ones that are settling down regressive, or different, multi-mode, if you will, like different. It thrusts, then it backs off, and it thrusts again. Like you can do it in solid, but it's sort of pre-programmed with the grain loading. Okay. And so. That's it's not nearly as say throttleable as usually liquid engines can have a lot more throttle control. Okay, and of course there's no relight. This is basically one and done. All right, and there is some thrust vector controls that can be done here, but it's usually not as much. So in fact, if you've been watching sort of the Starship landings. So Starship, these Raptor engines are gimbaling 30 degrees. That's actually quite crazy. A normal gimbal in a rocket engine might be 3 degrees. And I think the Virgin we did I think up to 10 because it was of our big pull-up maneuver. But 30 is pretty crazy. Usually you don't get that much out of here. It's just a couple degrees. So pretty challenging. Okay. But besides that, the rest of it is all the same. You have a thrust chamber, so that these gases are going to start burning. Is going to create hot exhaust that is going to then accelerate to a throat to Mach 1 and then convert that heat into exhaust, and it's going to end up building pressure. So your whole system here has to be able to hold it, right? So it's just the same as a liquid rocket engine chamber from that point of view. Okay, and the burn rate, the rate that this burns is usually some constant pressure to the end, and so it absolutely increases, the rate increases with pressure. Okay, and so it also depends on ambient pressure as well. Now I will add one other configuration here, so that this configuration might look exactly like what that solid rocket motor is doing in a missile configuration. Okay, for something that's actually flying, you actually will see what's called a blast tube, where you sort of extend your throat. And what you're doing here is you're actually just keeping the center of gravity. Sorry, center of gravity is wrong symbol. What, you guys can't see that very well, anyways. You're keeping that center of gravity for sort of the rest of the system, if you will, and but you push it there, so as you burn, your center of gravity isn't shifting. It gets hard to do shifting center of gravities with flight vehicles. Okay, so that sometimes that can create extra challenges to do the tube, but it's all kind of part of the engineering. All right, so failure modes. Let's talk through some of the bad things that can happen. Okay, so failure modes. A lot of times cracks will do it, and so you imagine getting some. I'll do it in red if you guys can see it, but if you have some sort of crack that extends like this, well, that's going to change the profile. It's going to increase the burning, which actually may increase the pressure, which may, your system may not be rated to handle such an increase in pressure if you had the right kind of crack. Okay, so cracks can get you. Basically, it's an unplanned burn. If that crack gets all the way to the wall, a lot of times it's just like regular rocket engines, that there's a thermal problem here. If it gets too close to the wall and it starts burning, then you're going to have issues, and you may have a kind of weaken the material and then go as well. Right? Temperature. There is a lot. Really, this whole thing sort of lights off with temperature, and so that's a lot of the kind of the handling. You kind of keep these in a dark, cold place. There's a lot of anyway, just temperature control on it from a point of view, and the failure modes. They kind of will talk about kind of different cook-off, right? So fast or slow cook-off being part of the modes that can happen. So there's a lot that goes into it. Now, a couple of different things, and now we're kind of transitioning a little bit into 13. Okay, so as we sort of talk about IC, this is sort of the generic stuff. As we get into sort of the different kinds of choices that you can do, you see some of the stuff here. Now, for one, lower temperatures, which ultimately are going to be kind of down here, the lower on the ISP, maybe not being shown. If you're something called a gas generator, that's a lower temperature device versus a solid rocket motor, which is more of a high temperature device, which is going to come up here. Now, you see some here, like reduce smoke. Some of that is important from a flight point of view. You see some of the higher energies, higher densities. Now, this specific gravity density, like this is way higher than a regular rocket motor. Kind of back to what I was saying with propellant density, and I showed other charts. I don't think I have it here. Other charts that really show you that dependency on sort of payload to orbit, if you will, based on the density of the propellant. So it can absolutely matter. And that's why even with lower ISPs, you do have rockets built purely out of solids that can get to orbit. They usually do it with multiple stages. Okay, and there's a great table. So table P6, I just call it the witch's brew. Okay, so I can't possibly highlight all of that table, but it's B6. Go look at it. Honestly, it's this crazy long list. This is just sort of a spectrum I wanted to show you here. This crazy long list of all the different solids and combinations and things like that. So just kind of like back, I flashed that ignition book that kind of showed all the different things that we tried on the liquid side. There's actually more and more on the solid side. It's almost I don't know if it's quite a factor of 10, but it's quite out there. So there's still a lot that maybe can be done and explored in the world of solid rocket motors, because there's just so many different unique configurations of kind of solid fuel and how solid oxidizer you can go through. Okay, there's one called like double base and composite base with different binders. You're seeing some of that here. Composites with some of the polymers. And so just the whole wide range. And maybe I'll just kind of finish this one by just saying that there's quite a lot between the fuel and then the aux and then the binder. Okay, the binder is something to help kind of hold it together, as well as sort of helps the curing process. And so kind of getting this to sort of bake in place. That's what they do. There's really this whole range of stuff. So The book does a decent job, but I really want to highlight here that this, especially that's why I called it Witch's Brew. Whenever you have something like this, that there really is just so much. It's both IP, but trade secrets, and then also just a lot of learning and things like that. So it's a fascinating field. I've only said it sort of had operational experience with solid motors, but I've certainly talked to a couple friends and colleagues that have had just a massive career in that world, enough to appreciate. Again, the pros and the cons of it, to appreciate really the care and handling and feeding. I got that from the operational point of view, but I will just sort of end with the possibilities of what you can do with some really advanced stuff. Like I don't think we've yet tapped out what we could do in the solid rocket motor regime. So that's it for these kind of two chapters, kind of 12 and 13. We'll come back. We're not quite done with solid motors. We've got another one more session on this to kind of get into a little bit more. So we'll see you there. Again, ask questions below, like and subscribe if you like the book club. And remember, part of this is you go read. I'm just hitting the wave tops. So go dig in. This is a great book. We'll see you next time.